Okay. Uh, okay, I'm running out of space on YouTube, so I would need your help to like and subscribe to my channel. Okay, anyway, this video will be on question 10 and question 11. So question 10 is about checking whether you are uh, good with your Newton's second law and also about your kinematic. So if you read the context, it says that at the very beginning, there's only one force acting on the object in 10.1. And you can see that from the context, there is actually no friction. So meaning that this 3 Newton will be your F net. So in this case, in your Newton's second law, you should be aware that Newton's second law consists of two parts. F net equals to ma is part of the law. Another part of the law says that your F net and your A must be in the same direction. So because of that, if you know the second part of the law, you can actually tell that the acceleration is forward as well. So because of that, as a result, your velocity is going to be forward as well. So in this case, what you can say is that the motion of this block is going to be speeding up, and it will speed up at a constant velocity because your net force is constant at 3 Newton. Now then the question introduces another scenario somewhere later on. So because 10.2 is what happened in the future later on, right? So we should know that the velocity initially is forward. So this is the initial velocity, right? It will be going forward because of this part. So now if you look at the forces acting on the object, you will see that there are actually a total of two forces. And if you sum them up, since they are on the same line of action, you can actually see that the F net will be -5, meaning that your F net will be in this direction. So if the F net is in this direction and you are aware of Newton's second law, you would know that now your acceleration will be in this direction. And we have learned that when your acceleration and your velocity are in opposite direction, it is basically an indication that your object is going to slow down. So once you have established all this information using your content knowledge and analyzing it properly, these are all the information that we can deduce. So once we have that, we can then decide which statement actually best fit what we have discovered. So 10a, it says that the object will stop moving. It is half correct. Eventually, it will stop moving for a little while. But the question is, will it remain stationary? So I will give you a sensing. For example, if now my initial v, right? My initial v is, let's say, 4 meters per second. Let's say. Okay. And my velocity, my acceleration, let's say is 2 meters per second square in this way. So what does this mean? This means that let's say I have all this thing. I start the time equals to 0 when my 8 Newton begin to act on the object. So therefore my velocity at the very beginning is 4, right? We say, and this 4 is in this direction, right? Because of this. So my acceleration will be 2 meters per second square in this direction. So meaning that after 1 second, my velocity should change by 2. And I should slow down by 2 because that is what we know. So therefore my new velocity will be this way. And since the 8 Newton is still acting there, my acceleration will still be this, right? So in the next second, my velocity would have dropped to 0. But when my velocity drops to 0, my 8 Newton is still acting there, correct or not? So therefore, my acceleration is still this. So yes, eventually it will come to an instantaneous stop. That means it stopped at 2 seconds. Because what happened next is that at the 3rd seconds, you will find that my velocity will actually become larger, because my acceleration is this way and it will be like that. And as time goes on, you can see that my velocity will actually keep getting bigger and bigger, but in the backward direction, because now my acceleration and velocity are in the same direction. This means that at this point, it is actually speeding up this way, but previously it is slowing down, right, as you can see over here, right? So in this case, my part A, the object will stop. It is half right, half wrong, okay? So I will just put it a tick and a cross. I will just keep in view, okay? I do not know, because when we are doing MCQ, we are supposed to pick the best option. Okay, so for A, I will just keep it like, oh, okay, it is not that bad, but not the best. Okay, so let's read on. B, the object will slow down, and that is true, right? Because that is what we have come up with. It will slow down. Then it says eventually stop. Oh, unfortunately, this is not true, right? Because it stopped for a moment, right? It doesn't stop and then zero, v is 0, v is 0, v is 0. It's not like v is 0 here, it's not like v is 0 here, right? So the velocity didn't stay 0, right? It actually become bigger, right? The magnitude become bigger. So I know that B is completely out. C, object will slow down, eventually move at constant speed. So if I look at my velocity over here, you can see that no, it's still changing, because my 8 Newton is still acting on the object. So I know that my C is also wrong. So it's like that. Oh, how come suddenly jump? Okay, here. And part D is slow down, true. Eventually move in the opposite direction. This is correct. Eventually it did move in the other direction, and it is a better option than A. So for me, I would pick D. Okay, for question 11, it is actually testing whether you are aware that when we analyze the motion of object, we need to analyze it axis by axis. So if we look at the plane actually move in either the y-axis, that means up and down, or the plane can actually move along the the z-axis, that means forward or backward. Okay, and of course the plane can actually also be moving in the left-right axis. We call this the x-axis. So for this particular context, there are only 2 axes in play. The plane is moving in constant height, meaning that on the y-axis, the plane is actually not moving. So your y-axis, right, your velocity is actually equals to 0. In another word, on the y-axis, the forces must be balanced. Okay, let's look at the gaining speed. Gaining speed meaning that it is going forward faster and faster, meaning that on the z-axis, the plane is actually accelerating, right? So on the z-axis, actually there is acceleration. So if there is acceleration, that means there is F net. And for our plane, there are 2 forces that is on the z-axis, which is your T, thrust, and your air resistance R. So in this case, we would know that your T must be larger than your R in order for the net force to be in this direction. Why? Because we already said for Newton's second law, there are 2 parts, the F net and the acceleration must be in the same direction. So because of that, since the question says I am gaining speed along the z-axis, it means that my acceleration must be forward. And if I know that my acceleration is forward, that means my F net must be forward. This means that my T must be larger than my R. So that's how I get this. So once you know that, you can just match it with your options, and you can see that your answer is C for cat.